Alright, I suppose this will be the first installment of a tutorial series that I'll try to make whenever I have time. And the more I figure out the software, then I suppose the more tools will be available. And as soon as I learn them, I'll be sure to compile a quick tutorial to post up somewhere for whoever decides to come across this video. So, right, so if you want to create a part, you want to go to Create New, and then you'll be greeted with this window. You probably won't have part design over here, so if you want to start, you'll just have like something saying start right there. What you want to do is click right here and click part design, and that should take you to this window. Right, so after that you would want to create a part body. There are several ways you can go about it. You can either click on here, or you could create a sketch, but I'd advise going with this. So you click on here to create a body, and click on creating a sketch. So there are three principal planes that you need to know about, really. So you have the oh boy, it's all flipped. So you have the YZ plane, which is this one, XZ, which is backwards, and YZ. The normal way of looking at a part is through an isometric view. So if you click on it, now you have the XZ plane oriented in this direction, you have the YZ plane oriented in this direction, and you have the XY plane oriented in this direction. This is usually how you're going to see parts being oriented in all engineering drawings. And you have this cube with various faces, that you might need to know about. So you have the front view, you have the front view, you have the right view, and you have the top view. That's usually the three views that give the most detail. Naturally, you have oh boy, you have the right view, you have the rear view, you have the bottom one. Oh no, that's top. That's front, bottom. Yeah, see, it gets confusing after a while. So if you get lost, just click right here to set it back to isometric view, and you should be good. So what you usually want to start with, probably 9 times out of 10, the way I do mine, is I work in the front, because that's usually where the majority of the details are in the parts that you'll be designing. So what you want to do is right here, you already clicked on create a sketch. So you'd want to click either on the plane or pick from over here. I just usually click on the plane and click OK. Now you see all these wonderful, let me move this thing out of the way, all these wonderful tools that are available to you. Majority of them we're not going to use because that will be outside the scope of this tutorial, but we'll use some of them. Okay, so let's try to make a table. A regular table is not going to be very crazy, but it should be a start to introduce you to some of the tools that are available. So you have right here, you have it in millimeters. You zoom out, you'll get more of the workspace in view, so you have a rough idea of what you're working with here. And the more you zoom in, the less, almost clicked off of there. You'll have a better idea of the scale of what you're working at. Right, so to move your workspace around, you use the middle, the mouse wheel to move your space around. You click on it and you drag it around. Yes. To select several things, you just click, drag and click and drag, but that'll come in handy later. So what you want to do is you want to create a rectangle at first, because we'll be making a rectangular table. So you create a rectangle in the sketch. So you have 2 points right here. See, you have 1 point there and 1 point there. So you select the origin. I think the origin is always a good place to start, and drag it out, say an arbitrary distance over here. Since we're dealing with millimeters, I don't think it's going to be an entirely big table. We can make it big. Why don't we? Okay, so first thing is you're going to want to constrain it. You'd want to constrain it, and you do that by using these, by using tools on this side of the screen. These ones are the ones that will let you create shapes. These are the ones that will let you constrain them. At least that's how I understand them with my about 30 minutes worth of knowledge so far. But yes, so what you would do is you would take this one, fixed length of the line or distance between a line and a vertex. I found this one to be the most versatile, so you would click on it. You see these lines. This indicates that it has the parallel constraint attached to it. Parallel, which means these two lines are parallel and these two lines are parallel. That also means they're perpendicular with each other. Say we were to make, say, a line. Say I want to make a rectangle like this. It wouldn't really work. Well, it would work. You would just need to use the constraint tool to align the 2 points together. Click on this point, and they should snap together like that. That's what constraint does, is it constrains the movement of two parts. But yeah, if you were to say make a rectangle using this method, it's probably not going to be very pretty, but you'll get the job done. So yes, when you use the point constraints, you just, oh, these two are already constrained. Would you look at that? That's interesting. I haven't had that happen to me yet. But yeah, you see you have this wonky type of rectangle. So you have a perpendicular constraint between two lines, so you click on one line and you click on another, and that would make them perpendicular to each other. It wouldn't make them perpendicular to the x-axis, unfortunately, but they would make them perpendicular to each other. There you go, now the constraint popped off. So you can go in here and click on these 2 points, and boom, you have a right degree angle, and these two are constrained together. Alright, say you want to make these two parallel, say this one and this one. Boom, now these two lines are parallel. This one and this one, we can also make them parallel. Boom. Now you have a slightly slanted rectangle, admittedly. The way you would try to write it, you could constrain one of them to the x-axis, and there you go. You should have a rectangle constrained with perpendicular lines and parallel lines. You can use any combination of the two, just play around, see what works for you. But the easiest way to make a rectangle I found was with the rectangle tool. Right, and whenever you want to deselect a tool, just right click on your mouse, and that should just deselect it. Say you had a perpendicular tool active. You see right under the cursor, right, you see the perpendicular symbol or the parallel symbol, for example, or the rectangle symbol. If you want to deselect it, just right click it and it should go away. So we would drag, select all this, and just hit delete, and that should get rid of any unwanted things you want to happen. Alright, so coming back from that tangent, you want to know the distance. So say you want to know the distance, so you click on this vector constraint, and that should give you the line segment that you selected. So say, let's say we want to make it, I don't know, what would be a good one? Let's say 5, no, not 5. 5 meters is too big. Let's say 2 meters. How many is 2 meters in millimeters? That's 2,000, I believe, right? So 2,000 millimeters, and boom, it shoots off in both directions. Oh boy. All right, that's okay. We can work with it, right? So you have a 2 meter long span going this way. Actually, to avoid all this, let's go deselect it. Let's make it small. 200 might be 2 meters might be a bit too much. Let's make it 200. It's going to be that's too much as well. Okay, how about 50? There, 50. We're going to make a nice small scale version of a table. See, Because it's not constrained, you can still move it around in all the areas that it's not constrained in. So you see, you have the distance constrained, which means this distance cannot change, which means if you drag this out, it's not going to move. Well, it's not going to change this distance, but if you drag this out, this distance can change because it's unconstrained. So if we don't want to change the length of this, we need to constrain it as well. It's a good idea to have as many things constrained as you can, generally speaking. So hit that tool. Oh yeah, you can also select the line that you want to use and then hit the tool, and that should bring up the menu. So let's say, let's make it 30 or 40. In keeping with the golden ratio, no, 30 I think would be better. The way to change it is you just double click it and it should bring you back. So see, now if you want to move this, you cannot move this, which means it's not constrained. One thing I personally like to do with this program, at least, because I haven't found really any other way of doing this, it's going to help us later on. So what you want to do is you want to constrain it to the origin. That'll help us later on when we're actually drawing like the legs out and the holes and stuff like that, trying to make the table a bit more useful. It would help with having at least one point on the origin. So the way to do that, how to constrain 2 points, you click on the point, you click on the constraint. Oh, see, yeah, now it gives you an error. So it says select 2 or more vertices from the sketch. So I only clicked 1, but it wants 2. So the way to select multiple is to just hold the control button and click on the 2 points. So see how they light up in green? So say you wanted to select these 2, you click one, press control, hit the other, and now you see that they're both green, which means they're both selected. So hit the points, 2 points, and click constrain to point. And yeah, that'll make them coincidence, that's the word. That'll make them coincident with each other, which means they are constrained together. And now you see that the whole rectangle has lit up in green, which means that it is fully constrained and you cannot move it at all. And that's generally speaking, a very good thing. Whew. Okay, so now we have our 50 by 30 millimeter rectangle. We have our sketch done. So we can click close right here. And here is our rectangle. See, we have jumped back into this view and we have this line basically drawn out, saying what kind of sketch we have. So yeah, see, if you click on front, there's our rectangle again. Click on this little circle right here to bring us back to isometric view. If you want to view it from, say, a slanted angle, oh, that's a bit too much. Go back to isometric. Say you want to view it from here, or not. Usually you'd be able to do it, but yeah, I suppose it's not. Okay, so what you want to do is you want to extrude it out. You want to make it from a 2D sketch into a 3D sketch. You want to add a dimension in this direction. So the way you do it is you want to hit pad right here or right here, whichever one you want. So hit pad and boom, you have a 3-dimensional block now. So right here you go into pad parameters and you'd click on how wide you want the piece to be. So say you want to create a 7, or I don't know, let's say 5. You'd obviously be going for whatever design specifications you have for your part. I'm just demonstrating the use of the tools here. Sorry, this talking is, I'm not used to talking, so my mouth is a little dry, so forgive my sipping. But so yeah, let's say 3 millimeters. That's a good table surface, right? So yeah, we click OK, and there's our rectangle, our tabletop. Say you want to inspect it. What you want to do is you want to click the middle button, the wheel, and the first mouse button, left mouse button rather. And you see how it turns from a pointer to a square with arrows in it. And if you click with the left mouse button, it turns into these 2 rotating arrows. And now you can rotate your part and see the back side. And you can see the cube also rotates with it. Yeah, so now you can inspect your part from all sides, just like that. It takes a little bit of getting used to, getting the orientation right, because sometimes if you do a simple motion like this, it can, because of the way the body is rotated in space, it often doesn't translate well to the part's orientation. So where you want to go back, you want to click isometric view, and there you go. Okay, so say we want to make table legs on this back. If we say that this is the top, we want to make some table legs right here, right? The way we want to do that is we would go back over here, click on this face, on the face that we want to draw our legs on. Click on there, and so you have face tools right here. We can create a sketch. As you see right here, you can also create a sketch from here. I'm not sure of this one, I haven't checked it out yet, but yeah, you can create a new sketch right here, or you can create a sketch right here. And boom, now we are right back to our sketch plane. Okay, so see, because we cannot highlight the borders of the rectangle anymore, because we have extruded it, this is why it helps to have at least one point constrained to the origin. At least that's what I found. So what we want to do is we want to create a rectangle. So create a rectangle and do our usual thing of zoom in, scroll in to zoom in, and constraint. Say we want to make it, what do you think would be a good width for a table leg? 7 millimeters by 7 millimeters. Yep, I think that's good. See, now it's all lit up in green, which means it's probably good. It's not probably good, it's definitely good. Yes, so now we go over here, do the same thing, make vertical constraints. Let's make coincidence again. You can coincide a point with a line, or not. I suppose not. This thing has a vertical constraint to it. Huh. I think one way you could do it is, yeah, don't forget to right click to remove any tools that you have. So you want to click on the vertical axis, press Control, and click on this. Okay. Well, I do not know how to do this just yet, so forgive me. It's going to be an unstable table for now. Okay, but at least we can figure it out later. Alright, I suppose I found a decent workaround. So basically what you would want to do, let me move this thing. What you want to do, so apparently it doesn't allow you to take distance to the axis, but because we have this constraint, we have this point constraint, we can use this line to constrain it with this line. So what you want to do is click on this point, click Control, hold Control, and click on this point. So, and select this horizontal tool. This will measure the horizontal distance between these 2 points. Because this point is constrained on the vertical axis, it should be fine for us to use this tool. So we can set it equal to 0, and that should, make this line coincidence with this edge of the table. This edge of the table is not done yet, so what we can do is use the same principle and make it coincident with this point, but only using the vertical tool now. Okay, now you want to do some geometry. So going back up, we want to find the distance between this point and this point. I believe we selected 30 for this length. So 30 minus 7, that should give us 23. So you select these 2 points again, click vertical constraint, and it was 23. And now this line should be coincident with the top of this, should be coincident with the table. Because this gets cluttered, you can always just click and drag these the measurements out of the way so that they don't obstruct your vision of your parts. You can always move them out of the way if you want, like, yeah, you can move them, you can move them in any direction that is along the line of your part. Okay, so we could do these again. That should be 7 millimeters and 7 millimeters. And there is another leg done. Yes. And go about the same process of constraining the other table legs too. So you could click, oh yeah, see now this point is selected, just click right click to remove it. Drag the part using the middle mouse button. Click on this point, showing horizontal. Let's see, this was 50 units, so this should be 50 minus 7, that should be 43. That lines it up with this. Say we want to use this point and this point, constrain it vertically. That should be 30 because it's this point right here and this point, and the length of this part is, the width rather, is 30 millimeters. There we go. Yeah, generally you should try to avoid doing this, but because it is not as intuitive as it should be, this will be good enough to constrain the parts. But that's, after all, that's what a lot of engineering is problem troubleshooting and problem solving around tools that you often have no idea about. But that's engineering for you. So there you go, now it's all green, meaning it's constrained. Zoom out, make our last rectangle. Constrain this with this. Vertically speaking, that should be 30. There we go. This with this. Oh, whoops. Yeah, see, we did the vertical length. We don't need the vertical length, we need the horizontal length. Click on this, click on this. There we go. Set that equal to 0. Now I have this edge constrained. And now select the width tool. Click on that, 7. And the width tool on this line should be 7 as well. There we go. There are our table legs. Now that we have our sketch done, we click close. Let it load up, and there we go. We have sketched on this plane only. Right, now what we'd like to do is we'd like to build material in this direction using this sketch that we've drawn. What it basically is looking for whenever it creates a pad or a pocket is like a hole basically that you're trying to make that with that sketch. So yeah, what we're trying to do is we're trying to pad it, which means we're trying to build material in this. And it's looking for closed shapes. So anything that's a closed shaped in whatever sketch that you've done, and that will be considered for a pad. And if it's not closed sketch, then it will most likely throw an error. So hit pad, and there you go. It is going to extrude in this direction using the sketch that you've made for however long you want the table legs to be. Let's say 30. Yeah, why not? Let's say 30. 30 millimeters. Does that look like a decent table to you? Looks one of the shittest tables I've ever seen, but I suppose it'll do, right? Okay, so 30 millimeters, that's good. That's acceptable. Let's go back to isometric view. Isometric view doesn't work. Measure distance. There was a fit to screen here somewhere that I saw, but you can always use this movement, the middle mouse button, to move your part in case you don't see it. Oh, here we go. Zoom to fit. Say you're like really close and you're trying to zoom to fit, trying to see the whole part again. You just click over here, click zoom to fit. There are different views. You can have orthographic view, you can have isometric projection, perspective. Kind of screws up your part in various dimensions. So just stick to isometric. Should be fine. Okay, right. So our shop table doesn't really have a whole lot of functions. So why don't we create some holes in which we can put some drills or whatever. What we're going to do is create the face on which we want to sketch. So create this, click on this, and that should highlight this part, this side of the table. So now we've selected the face. We click create sketch. Hold on. Create sketch. Oh, I've never seen this one, but I suppose we'll just go with the recommended. And oh boy, what the hell is going on? Okay. So yes, click. Now we screwed up the alignment. We just click on front, and there we go. We should be perpendicular to the table again. Okay. So say we want to make a hole, right? Say we want to make. Oh, what the hell? Some fucking orthographic. Okay, there we go. Make sure it's an orthographic instead of perspective, because perspective kind of shifts your perspective a lot. So yeah, use orthographic for engineering drawings. Yeah, that way you don't have a weird parallax going on. Okay. Yeah. By the way, this is also me just learning. It's my second time trying to make this. Trying to make a part in FreeCAD. Anyway, okay. But it's a learning process. We'll figure it out as we go. Say we want to make a circular hole. So we go over here, create a circle in Sketcher. And we can make let's say a circle like that, okay? Do you want two circles? Why not? Let's make one big one and one small one. Ah, come on. Every circle needs a friend, right? Make it a group. Group of 3 circles. And because they're not constrained, you can still move the radius around by clicking on the outer edge. If you want to move the whole circle, click on the dot in the center. There you go. Okay. Say, yeah, it should be fine. Okay, click front there to recenter it. Say we want to have our holes here somewhere. Yeah, you got to remember that you have a leg right here, so you cannot move it right here and have a hole going through the leg. That would make it unpleasant, I would imagine, but it's okay. So now we have to get back to constraining it. See, it helps to have an origin point already on the part, because you cannot constrain in relation to this, at least not in any meaningful way that I've found. But I'm sure there's a way, but I haven't found it yet. So yeah, let's go from smaller to bigger circles. So again, we have to go to constraint. Oh dear, okay, that doesn't like, my sound system doesn't like sounds like that. Okay, so click on the vertical axis right here, click Control, and click on the dot. That should select them both. Great. Click on that to measure between the two, and there you go. So our leg was 7 millimeters, so it's like right here somewhere. Let's put the whole. Yeah, let's put the whole 13 millimeters away from here. How about that? There we go. Now the hole is constrained, and you cannot move it in this direction. You can move it up and down, but you cannot move it in this direction, inside the set, because it's not constrained. Right. Do the same thing over here. let's say, oh yeah, the reason it is negative because it is below the axis that it's below in the negative area of the plane. So whenever it just says negative like that, do not worry about it. That just denotes direction in which it's going. Like say if you wanted to put it in 5, it's going to take it outside of the park right there. So yeah, so the negative or positive just denotes direction on which side of the axis you're dealing with. So put negative, and that should bring it over here. Okay, but I figure that's too much. I think it's okay. Okay, now you want to constrain the radius. I believe you could just simply click. Oh, no, that's not how it works. Okay, yes, you go to constrain an arc or a circle. You click on this drop down, you constrain either radius or diameter. Let's go to radius. Doesn't really matter, potato, potato, they both explain the circle in the same way, just slightly different. Okay, radius, let's say 3 millimeters. And there you go. You should have a constrained circle, I believe. Sometimes parts do not light up in green, which I'm not sure why this one does not, because it appears to be fully constrained, but sometimes they're fidgety like that. Don't forget, you can always move measurements out of the way so you can see better. Right, so we want to make them inline. So click constrain between point and vertical. Yeah, I was holding control there. So it should be 5. Let's say that was 3 millimeters. Horizontal distance between these two radii. You could just do between these two or this line over here. It doesn't really matter. Just be sure you're clicking control and the centers of the two circles. Let's make them 10 millimeters apart. Why not? There we go. 10 millimeters. Right click to remove the tool, and there we go. Can still make the circle bigger, which means it's not constrained in the radius. Can easily fix that. Let's do diameter this time, why don't we? So this has a diameter of 6 because diameter is radius times 2. So click on the circle. So the diameter of 6. Let's make this diameter of 5. There we go. Now it's slightly smaller. Right click to remove. Oh, interesting. So yeah, you can also create stuff by right clicking on things. That's neat. Okay, and let's add another one. Another circle. Yeah, I believe these are all constrained. Yep. Okay. Click on this. Click on this. Vertical distance -5 millimeters. Oops. -5 millimeters. Distance between these two was 10, so yeah, let's make this one 10 as well. Click control so it doesn't freak out. And 10 millimeters. 10 millimeters, and now it's time to constrain the radius again. Okay, so this was 5. Let's make this diameter. Diameter of 4. Yes, you can see the tool when it has a line through there. That means diameter. When it has half a line, it means radius. Oh, now they're all beautifully constrained with each other. See, now they're green. All right, so you would zoom out, which means now we're done with the sketch. Click close, and there we go. We have kind of our holes drafted already right there. So what we want to do is we go into the model view. Right, I should explain this. So we have this body. What the hell? Right, so we have this body and we have this sketch that we've made on there, this sketch. So we want to select this sketch, which has these circles on it, and we want to create a pocket. Yes, and if you double click on it, it will back to the editing mode. Yes, it'll go back to the editing mode. So you have this pocket tool. Pocket basically creates either a hole, a through hole, or an indentation, or anything that takes away material. Whereas where pad was adding material, the pocket tool is taking away material. I think all of these ones are the ones that are adding material in various different ways. And these ones with blue and red are the ones that take away material. I suppose, yes. I believe so. So if you see anything that's yellow is adding and red is subtracting, I guess, is the pattern here. But anyway, so you have the sketch selected right here in your tray. Click pocket. And now you get to choose how deep you want the pocket to be. If you want to make it go through all the way, you'd click on this dimension and click through all. And that should give you, oh boy, oh my god, come on now. Oh, you son of a bitch, don't embarrass me like this. Okay, let's see. Alright. Right, so I believe I have found the problem here is because I have two different bodies somehow, and one is interfering with another. So I need to move this sketch onto this body, which is the actual one that we should be working on, instead of this, which, if deleted, does nothing. Actually, now that it's gone, here we go. Maybe I won't have to go through a laborious process of recreating it on this body. But in theory, you should hit the pocket tool, make independent copy. Okay, perfect. There we go. So yes, you had to make sure that copy sketch. Oh my god, parts are appearing out of all over the place. But it's okay. We can always delete them. Pad, copy pad. I don't think this one is also necessary. Make sure you want to continue. Shit. Oh, no, it's not. Anyway, okay, so create this, click on the sketch, highlight it, click on the pocket tool, make independent copy, I guess. Right, and so now you see it is making an indentation in the table. Or it drills a hole through the whole table because our length is 5 millimeters. But say we didn't want to make an indent, a hole through the table, we could make it as deep as we want. Say we wanted to have it 2 millimeters because it doesn't exceed the depth of our this length, the depth of our table. It kind of makes these cup holders, cup holder looking objects right there. But because we're trying to hang tools in there and stuff, we can go to the dimension and through all, and that would make holes throughout the entire part. Right, so we go back to isometric. Oh, okay. Yes, don't forget you can always rotate parts. It takes a little bit of getting used to, but I believe it rotates it about the origin. So wherever the origin was, that's where it rotates it. Okay, so now we have holes done. Click OK. And there we go. Should have our holes ready. Yep. All right. Now our table has a lot of sharp edges. Delete. Oh my god, it didn't do anything. What if we delete this? Oh my god, that's much better. Even though the sketch is deleted, we cannot really alter it anymore. It's always good to have your sketches available, but I suppose we don't need this. It just makes it look ugly. But yeah, so say we wanted to alter this sketch, say change this hole to a 2 millimeter hole. Close. It should alter it. No, it does not want to alter it. Why the hell do you not alter it? You should alter it. Okay. Oh, it's using a copy sketch. Okay, so now it's using a copy sketch. So you go over here, put it on 2. It should make the hole smaller. Yes, see, now it has made the hole smaller. This sketch is garbage. So yes, so the dependencies are what they have right under them. So because we edited this copy sketch right here, double clicked on it, and changed this dimension, so we'll go back to not 33, go back to 3, it enlarged the hole, click close, and it made the hole bigger. So if you want to change, say this first pad that we made with this table, if you want to make the table longer, you can just go in here, go into this sketch, and change these two dimensions. Now let's do that. Why don't we? Say we want to make a 70 by 50 table. Boom. We could have a little bigger table. Close. The legs are going to be fucked up, but you get the idea. Because they're constrained to each other and not to the edge of the table. That's why they're able to move. They're not moving because they're constrained to each other instead of the edge of the table. Once I've figured that out, I'll let you know. But for now, undo. For that, we must undo. 50 by 30, close. There we go. There's our table. Yeah, sometimes it gets confusing, so just click isometric, right click, zoom to fit, boom. There we go. Orthographic. Yeah, perspective kind of sucks, so don't use perspective. Just use orthographic projections. That's much better. Okay, now as I was saying, we have a lot of these sharp edges that some poor unfortunate soul might meet with their hips or their whatever unfortunate body parts happen to occupy the same space as the angle. So what you want to do is you want to click on the edges, right click them, and we can round them out a bit. So see, I have clicked and I have selected all of these edges. See how they're glowing in green? So we would like to make them a little bit rounder, just to make them a little bit safer for people. So how we would go about it is we could fillet it, which would mean it would round it out to a specific radius that we would like. So you see now it has selected several edges right here, this edge, this edge, this edge, and this edge, and we can decide on which radius we want to round it out to. So we have 1, we have 2, if it decides. Yes, see, now I have 2 and it's made it a little bit bigger. 22 is probably going to crash the thing, which we don't want to happen. So go back to 1. I think 1 is sufficient. Click OK. And there you go. Now I have a nice rounded edge. Another way of doing it, a much easier way in my opinion, just click on the face, the entire face. So you click tasks and click on this fillet thing. Click radius 1. Click OK. Oh, failed to create fillets. I suppose not. It's probably because of these holes. It's getting confused. So yes, what you could do is just round them out like this, and it should be fine. There, create fillet, and there you go. You have rounded out your part. Say you don't want it to be at any radius. Yeah, just to confirm that it's a radius. Here is the curvature of it. It's constraining itself to a certain radius, and it's smoothing the part out. Right, now if you want to make them at an angle instead of it being curved, you can use this chamfer tool, which basically smooths it out at a certain angle, I believe. So say let's do it to these legs. Let's do it to the legs. So click on this. By the way, you have to release of the control whenever you want to rotate. Don't worry, it's not going to deselect the edges. You have to be careful to click on the edges again. So pressing control again, selecting these two edges. So yes, now I have all 4 of these edges selected. Click chamfer and say we want to create 1 millimeter chamfer. Why do you not want to do this? Why are you being so difficult? Okay, so I suppose we can just do it one by one. Okay, something is wrong. Why are you so frustrating to use? Is it because you're connected to this? Possibly. I don't fucking know. Okay, let's click on this one. Chamfer it. Aha, there we go. Alright, sure, let me just demonstrate the chamfer tool here. So yes, I suppose if I were to guess, it's because it's interfering with the fillets that we've made up there, and it being not smooth over here. So yes, so here is, I suppose, for some reason this is going to work. So yes, if we want like a 1 millimeter, I believe 1 millimeter is this distance right here. I think it does it at a 45-degree angle. There should be a way to change parameters, but it does not want to do that. Okay, so this is what a chamfer. Oh my god. Okay, 1 millimeter chamfer. There we go. So let's say you have 1 millimeter chamfer for whatever space you might need that for. You know, you might hear me getting more and more frustrated at this, but it's okay. So we can just select all of these and chamfer them just the same. There we go. How about that? That took way too much. Too much of my life away. Okay. Yeah. I think CATIA is much better. Much better at making parts. Yeah, so back to an orthographic view. So this is our table, I believe. These are all different views that you can look at it from. And this is it right side up, supposedly. So this is a basic overview of what each tools look like. We've went over the pad tool, which adds material, the pocket tool, which takes away material, the fillet, which rounds out the edges, and the chamfer, which cuts away the edges at a 45-degree angle. Right, so I suppose this is a basic overview of how to make a part in FreeCAD. So enjoy, don't cry too much. Peace.